Hi, Dr. Zhang. This is Team VTG, and we're here to present to you our Ball on Beam project. I'm Jeff Terraby. This is Vince Tedesco.
I'm Vince Tedesco.
Raymond Krause.
This is John O'Neill.
And Hubert.
SolidWorks. For our design of the beam, we actually modeled it up in SolidWorks first. And you can see we have an example of our beam created here. And you'll see it's basically what we ended up fabricating. And we just chose the simple seesaw type design.
Right, what about the dimensions? What do we got?
So we got 20-inch long beam, 10 inches on each side. Our ball has the capability to balance back and forth 5 inches on each side. Right now it's balanced at its middle point. We cut everything out of acrylic using the laser jet out of the machine shop and made all of our holes and drilling with the mill.
Okay. So now it's actually about control algorithm implementation. Alright, so we decided to use Arduino coding with a linear potentiometer. And as you can see here, this is our block diagram. Pretty simple block diagram we got going on for the actual system itself. We have our input XR, we have our PID control, which is actually our servo motor. We have disturbance coming in, anything like disturbing the system, like we accidentally bump into it, anything that happens, like as of right now we have some noise, servo's kind of busted from the cold weather, I don't know, but whatever the disturbance is. Then we have the actual system itself, and since we don't have a spring or a damper, we pretty much just have the mass of the ball, and we have our output. Now, once we get our output, we read the new position and velocity from our PID with our potentiometer, which relates Kp, as you can see, to the angle at which the beam is at, and Kd relates it to the velocity. As you can tell right now, we have Kp is equal to 1, and Kd is 0.5. And with Kd at 0.5, the system is slightly underdamped, as if we push it a little bit, it's going to slowly go back to the center, not quickly right back to where we want it. It'll kind of rock back and forth, as we can demonstrate in a little bit. Now these are the equations we used for figuring out what x over xr should be for our transfer function, and this is what we get with all the values put into that. And it's pretty simple. It's a pretty simple systems problem that we have here.
So I want to look at the beam again, a little demonstration which you've seen before. As John was mentioning before, it is slightly underdamped, and really our main reasoning for underdamping the system is because if it was overdamped, really it would become a catapult, because it would try to correct itself too quickly, and the ball would leave the beam and maybe jump over here, and that would create some pretty, extreme readings for the potentiometer, and really the system wouldn't really be able to compensate for that. So we underdamped it slightly. It does slow it down a little bit in terms of finding the equilibrium point to get at the center, but it keeps the ball on and actually achieves the project requirements.
Okay,
so I guess to reflect on the project, overall it really got us to learn how to use Arduino, microcontrolling, and using a physical computing system here, which is what the Arduino does. It serves as the connection between the code that we've written that we'll be submitting to you and the ball on beam apparatus that you see here.
We were pretty happy with our results. Our goal for the project was to be able to balance the ball 4 inches on each side and bring it back to the middle. We were actually able to do 5 inches on each side and bring it back to the middle. We were also able to manipulate our code so that the servo would actually believe, the servo and Arduino board would actually believe that the center point of our beam was either 1 or 2 inches to the right or 1 or 2 inches to the left, and the ball would actually balance at that point. So we were very happy with the performance of our beam in that aspect.
This project enabled us to take what we had learned in class, which was really a lot of theoretical, written down notes and
like the block diagrams.
Yeah, like the block diagrams here, and turn it into an actual project and see how systems controls actually operate.
Okay, well, Dr. Zhang, that was our video of Vince Tedesco Group of our beam, and I hope you have a nice holiday.